Welcome to Math 9. Today we're just going to do a review of polynomials and the introduction that we started already. And today we're just going to look at the language associated with polynomials. We'll look at what the terms mean, how to determine a degree, and just looking at how you can tell the number of terms. First of all, I want to just remind you of some terms in an expression. So if I have an expression like 5a plus 3b minus 2c plus 9, in here we have variables. The variables are the letters, so the a, the b, and the c. Hopefully this is a review for you. So the letters that we see are variables. Okay, next, the numbers that are multiplied to the variable. They're attached to the variable, so the 5, the 3, and the 2. These numbers are called coefficients. Okay, and last, when you have a number that doesn't have a variable attached to it, it's called a constant. Okay, next, let's take a look at the names for polynomials, and we will classify these based on the number of terms that are in the polynomial. So let's just review what a polynomial is and what these names are. So a polynomial is an algebraic expression made up of terms that are connected by operations of addition and subtraction. So for example, 3x squared minus 4 has two terms because 3x squared and 4 is connected with the operation of subtraction. Okay, all expressions with one or more terms are polynomials. Polynomial means many terms, and if you have just one term, it's a monomial. 2 terms, binomial. 3 terms is a trinomial. And polynomials are made up of terms. Terms are connected by addition and subtraction. Okay, so back up to here. Classify each of these according to what type of polynomial they are and state the number of terms. So when I look at counting the number of terms, I'm counting the expressions that are separated by plus or minus signs. So 4xy plus 3. That's 2 terms. And 2 terms is a binomial. Okay, B, 7a squared minus 2ab plus b squared. So 3 terms. 3 terms is a trinomial. Okay, C, 5x squared plus y squared plus z squared minus x minus 6. 5 terms. We don't have a special name for a 5-term polynomial, so we'll just call it a polynomial. Okay, 13 is 1 term, and a 1 term is a monomial. Okay, 13 is also a constant, so I just want you to also be aware that if it were 13y, that's still a monomial, 1 term. So it could be a constant. It could also have variables attached to it. Okay, next I'd like to look at the degree of terms. So we're going to look at what is a degree of a term. What then is the degree of a polynomial? So when you have just one term, like 3xz, the x has an exponent of 1, the z has an exponent of 1, Because this is one term, you'll add the exponents together. 1 plus 1 is 2. So this has a degree 2. If you have 5x squared y, here we'll add the exponents. So 2 plus 1 is 3. So this is degree 3. Just as negative 2b cubed is degree 3. So for the degree of a term, you're looking at the exponents in the exponents that are attached to the variables. Okay, to get the degree of a polynomial, so now you're looking at where it's a binomial, trinomial, or just a 4-term polynomial, anything like that. What you're going to do is take a look at each term individually. Okay, so here the exponent is a 2, so this term is degree 2. This term, it's a to the 1, so this is degree 1. What you're looking for is the highest degree. Because this is a 2 and this is a 1, we go with the 2. So this expression altogether is degree 2. Okay, number of terms. So we can count the number of terms. 1, 2. And I'm just going to count all the number of terms first of all. Then we'll come back and do the degree after. B is 3. C has 3 terms. And D, 1. Okay, degree of polynomial. So look for the variable, look at the exponent. So this is a 2. This is the highest exponent in the whole expression. So that is the degree of the polynomial. B, a squared. This term is degree 2. A to the 1, b to the 1 adds to b, degree 2. And b squared is also degree 2. So the highest is degree 2. X to the 1, Z to the 1. Those are the variables, and both are 1, so degree 1. 7 doesn't have a variable attached to it, so this is called degree 0. Okay, last thing we're going to look at today is modeling polynomials. And we look at being able to draw the model for an expression using tiles. And then the other thing is that we can use tiles to write an expression. So first of all, just about the tiles. In our textbook, they color them green and red if they're positive, and they leave them white if they're negative. If you get a photocopy of something, gray or shaded is considered positive, and unshaded would be considered negative. Okay, next, take a look at the size of the tiles. We have a small square, and these are the constants. Okay, and then we have a rectangular tile. These are the X tiles. And then we have a larger square, and they're called the X squared tiles. The number, the leading coefficient or the coefficient out in front tells us how many we need to draw. So 3x. 3x, they're positive, so I will draw 3x tiles and I will shade it. And plus 2, these are constants, so I will draw in 2 positive constant tiles. So that represents 3x plus 2. B. B is negative x squared minus 2. So negative x squared, the x squared is the larger square tile and unshaded. Minus 2, I'm going to draw 2 unshaded square tiles. X squared minus 2. Okay, 2x squared plus 3 minus x. 2x squared, so I need to draw 2 larger squares and shade them. I'll draw 3 constant tiles and shade them, and 1 X tile that's negative, so I'll leave it unshaded. And that represents the expression. Okay, you can see here that the 3 examples that we did here, I've got the tiles laid out for the 3, for A, for B, and for C. Okay, and last, you can draw one here. One thing that we are going to do with it is, can you name the expression that represents this picture? So same thing. This represents an x squared. I have one of them, and it's shaded, so it's positive. So this would be an x squared. I can put 1x squared if I want, but I could just leave it as x squared because the 1 is implied without writing it. Here I have x tiles, 1, 2, 3 of them. They're positive, so I will write plus 3x. So this plus sign indicates that this is positive here, plus 3x. And I have 4 constant tiles that are negative, so minus 4. Noticing that all of these terms